Welcome to this module, Machine Learning on Azure. Building machine learning solutions is a core part of modern AI. It involves using data to create models that can make predictions, power recommendations, and provide new insights. This process follows a structured life cycle to ensure solutions are cost-effective, fast, and accurate. The Machine Learning Lifecycle. The process of building a machine learning solution can be broken down into a few key steps. Define the problem. Clearly state what the model needs to predict and how you'll measure its success. Your data and your model's goal will point you to the correct machine learning task. Here are some common types of machine learning tasks. Classification. Predict a categorical value. Regression. Predict a numerical value. Time series forecasting. Predict future numerical values based on time series data. Computer vision. Classify images or detect objects in images. Natural language processing, NLP, extract insights from text. To train a model, you select an algorithm based on the task you need to complete. After training, you evaluate the model using specific metrics, like accuracy or precision. These metrics help you decide if the model successfully performs its task. Get and prepare data. Data is the cornerstone of machine learning, and both its volume and integrity are crucial for a model's performance. To train a model, you must first define the data's origin and structure, decide how to deliver it, and create a system for bringing it in. This process, known as data ingestion, involves extracting and preparing the data so it can be used for training or making predictions with an Azure service. Before you can use data, you need to prepare it. A common and effective method is called ETL, Extract, Transform, Load, or ELT, Extract, Load, Transform. This process ensures your data is clean and ready for analysis, which is essential for things like training machine learning models. To move and prepare data, you can build a data ingestion pipeline. This is a series of automated tasks that handle the data flow. You can run these pipelines manually or on a schedule using Azure services like Azure Synapse Analytics, Azure Databricks, and Azure Machine Learning. Training a model on Azure. Azure provides a variety of services for training machine learning models, each suited for different needs. Azure Machine Learning offers a flexible platform to develop and manage machine learning models. You can either use a graphical interface in the studio or work with code using the Python SDK and CLI, depending on your preference. Azure AI Services, a collection of pre-trained machine learning models available through an API. These services enable developers to quickly add AI capabilities for common tasks like object detection without building a model from scratch. Azure Databricks, a powerful data analytics platform that uses distributed Spark compute to process data at scale. It's ideal for data engineering and data science workloads, where you need to handle massive datasets. Microsoft Fabric, a unified analytics platform that brings together the work of data professionals in a single environment. It allows you to handle the entire data workflow, from preparing data to training models and creating visualizations. Our focus will be on Azure Machine Learning. Azure Machine Learning, Azure ML, is a cloud service for training, deploying, and managing machine learning models. It helps data professionals and engineers manage the entire lifecycle of their ML projects. Azure Machine Learning, Azure ML, is a comprehensive cloud service designed to streamline the entire machine learning project lifecycle, from data preparation to model deployment. It offers a range of tools and capabilities to support various tasks, including data exploration, model training, and management. Key features include centralized storage for datasets, on-demand compute resources for running jobs, and automated machine learning, AutoML, to help find the best model. The platform also provides visual tools for building orchestrated pipelines and seamless integration with popular frameworks like MLflow. Furthermore, Azure ML has built-in support for responsible AI principles, allowing users to assess model explainability and fairness. Provisioning Azure Machine Learning resources. To start using Azure Machine Learning, you first need to create a workspace in the Azure portal, which will automatically provision other necessary resources. Choosing Compute for training. When training a model with Azure Machine Learning, you'll need to choose compute resources to run the process. It's important to monitor both time and cost to find the right balance. CPU versus GPU. For smaller tabular datasets, a CPU is sufficient and cost-effective. For unstructured data like images or text, GPUs are more powerful and efficient. GPUs can also be used for larger tabular datasets if a CPU is proving to be insufficient. When you use Azure's automated machine learning, you don't have to worry about selecting compute. It's handled for you, simplifying the process. Deploying and integrating a model. After training, the ultimate goal is to integrate the model into an application to get predictions. You do this by deploying the model to an endpoint, which is a web address your application can call to get a response. You have two main options for deployment, which impact both cost and performance. Real-time predictions. Use a real-time endpoint when you need to score new data as it arrives and get a response immediately. This is ideal for applications like a website that provides instant product recommendations. Because the model must be ready to respond at any time, the compute for a real-time endpoint is always on, leading to continuous costs. Batch predictions. Use a batch endpoint when you need to score a large amount of data at once and don't require an immediate response. For example, a model that predicts weekly sales can be run on a schedule, with the results saved to a database for later use in a report. The compute for a batch endpoint is on demand and can be scaled down to 0 when idle, making it a more cost-effective option. To decide between the two, consider how frequently and how quickly do you need predictions? Should they be generated one at a time or in batches? What is the cost of the compute required for each approach? To recap, building machine learning solutions on Azure involves a structured process that includes defining the problem, preparing data, and training a model. Azure offers flexible services for these tasks, and you can choose the right compute resources for both training and deployment, based on your performance and cost needs. The final step is to deploy the model to an endpoint for either real-time or batch predictions. Next, we'll look at the fundamental principles of natural language processing.